Welcome to Stephen Lee's Acting Professor Lecture on Insertion Sort for CSC 172 at the University of Rochester. As you can see in front of me, we have a variety of items that are already sorted from smallest to largest. Never mind how I acquired these items, that'll be a video for a different time. Now with a little movie magic, we're going to scramble these items, and hopefully by the end of the video, by using Insertion Sort, we will get these items back to this exact order. Ready? Here we go. As you can see, our items have now been randomly assorted. Now if you imagine all of these items are in an array, with Stitch being at index 0, and this peanut butter bar being at index 15, then basically our end goal, when given this array of items, is we want to sort them so that index 0 contains the smallest item and index 15 contains the largest. Now how insertion sort works is that we're going to take these list of items and we're going to split it into two parts. One part of the array will already be sorted, and the other part of the array are going to be the items that we go through. So we're going to iterate down the line, and then we're going to compare each item to where it belongs in the sorted section of the array. It'll make sense as we go along. So if we start at index 0, let's say that Stitch is already sorted, and that if it were an array of one item long, then we've already marked it from least to greatest. So we're going to move on. So if you imagine there's a line here now, with this side being the sorted side and this side being the unsorted side, we're going to go down the line and we're going to compare the item to how it amounts to relative to the size of Stitch. Now we have Bulbasaur here. Bulbasaur is smaller than Stitch, and because he's smaller, we're gonna switch these two items, and now we're going to mark index 1 as the sorted array. So, like previously noted, if this draws the line between sorted and unsorted, then we can now see that if we had an array of 2 items long, of containing just Bulbasaur and Stitch, that this array right here would be sorted. So let's move down the line until we've sorted all the unsorted items into our sorted array. Let's see how the candy compares. Well, the candy is certainly smaller than Stitch, so we're going to swap these two indexes. And the candy is smaller than Bulbasaur, and we're going to swap these two. Now we have a new sorted array section of length 3, and we're going to keep going down the line. Let's see how Squirtle compares. Squirtle is smaller than Stitch, so we'll swap them. And Squirtle is larger than Bulbasaur. Now the reason why we don't need to check if Squirtle is bigger than the candy is because we know that this array has already been sorted from least to greatest, or from smallest to largest, excuse me. And for that reason, we know that as soon as we compare an item, and that item is larger than the item that it is being compared to, we don't need to compare it with any of the items before that, because those items were smaller than that item. So let's move forward. This hairpin is smaller than Stitch, so we'll swap them. But it's larger than Squirtle, so we'll stay put. Alright, this fish is larger than any of the objects we've compared it to, so we don't need to worry about where it goes. Pikachu is smaller than this, so we'll swap them. Pikachu is slightly smaller than this one, so we can switch them. And he's larger than the hairpin, so we can leave it there. Once again, here's our sorted section, here's our unsorted section. Move down the line to Charmander, who's smaller than this fish. Charmander is also smaller than this, and he's smaller than Pikachu. But he's bigger than the hairpin, so we can just let him stay. Let's move on. This little hedgehog, oh, he's so cute, is smaller than basically every item we've compared him to. So he can stay here, all the way at the edge. The Milky Way bar is smaller than this, but it's larger than Stitch, so we can put it here. Once again, as you can slowly start to see, all the items towards the left are now sorted, and the unsorted items remain to the right. Let's continue. This Sharpie is smaller than the fish, so it goes here. This pen cap is smaller than that, smaller than this, smaller than that, and this, and Pikachu. But is it bigger than Charmander? It is bigger than Charmander, and we can double check with Pikachu here. It's slightly smaller than Pikachu, so we'll put the pen cap there. The single AirPod. Smaller, 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 smaller. Ooh, is it larger than Bulbasaur? It's slightly larger than Bulbasaur, but it's certainly smaller than Squirtle. So we're going to shift everything down. So while I'm taking a shortcut and I'm finding the smallest place where the AirPod go, please be reminded that it's going to swap the index of where it is. And for the next item that is smallest, I won't do the shortcuts, and you guys can see what I mean by that. This item is the largest item, so it stays there. This little guy, and here's what I mean by switching indexes, is smaller than this, so it'll switch. It's smaller than the fish, so it'll switch. It's smaller than the Sharpie, smaller than the Milky Way, and Stitch, and Pikachu, and the pen cap, and Charmander, and the hairpin, and Squirtle, but it's slightly larger than the AirPod. Finally, we have all of these things sorted, and we're just missing the peanut butter bar. We compare it to this one, it swaps, it's smaller. We compare it to the fish, we swap, because it's smaller. And we compare it to the Sharpie, and it's bigger, which means it stays. And as you can see, now we've successfully sorted our 16 items from smallest to largest using Insertion Sort.